Okay, hi everyone. So today we have question 24 from SJPO 2016. So we're given a question on inelastic collisions, and the reason we know it's inelastic is because the two skaters, they hold hands after they collide, which means that they stick together, right? And they move as one combined mass. So we know that in the inelastic collisions, right, the maximum kinetic energy is lost, right? So the two scenarios are roughly as follows. Case 1, we have a 80 kg fella that is moving towards a 20 kg guy who is stationary, okay, at some speed u, at some initial velocity u. In case 2, we have the opposite scenario. We have a 20 kg guy that is moving towards the 80 kg guy, but the speed of the 20 kg guy is going to be faster, and it's going to be at the speed such that, right, the initial kinetic energy of both systems are the same. And so we can calculate this speed, and to calculate this speed, we calculate the kinetic energy of the first system, right, which is just half times 80 times u squared, which is 40 u squared. So in order to have if we don't know what this speed is, let's call it u prime, right? If we don't know what this initial speed is, then we can try to figure it out by doing half times 20 times u prime squared is equals to 40 u squared, right? And solving this out, we get that u prime squared is equals to 4u squared, or u prime equals to 2u, right? So we know that the initial velocity for the second scenario is 2u, is twice the initial velocity in the first scenario. Okay, so now we have the initial kinetic energies, but that's all we care about, the kinetic energies, right? The kinetic energies are only useful for deriving the speed in the second scenario, and the reason is because in a perfectly inelastic collision, or in fact for any inelastic collision, the kinetic energy is lost, right? In this case, we know that the coefficient of restitution is 0 and whatnot, but the point is, how we're going to figure out the final velocity of two objects, right, after the collision is that we're going to figure it out by considering them as a combined mass of 100 kgs, and after that they're moving together at some final velocity v. So we can use conservation of linear momentum to figure this out. So we have 80u, so the initial momentum is 80u plus the 20 kg times 0, right, because the 20 kg is not moving. So this is equals to 100 times v. Okay, and we get that v is equals to 4/5u. Okay, how about the second scenario? Like a second scenario, we have that the 20 kg guy is moving towards the 80 kg guy. After that, they combine, right, into effectively a 100 kg mass that's moving at v prime. So moving at v prime, and v prime is given by, right, so by conservation of momentum. So the initial momentum is 20 times 2u, right, and the final momentum is 100 kg times v prime. So this will give us 40u equals to 100 v prime, or v prime is equals to 2/5u. Okay, so yeah, so if we compare these two results, the ratio of the change in kinetic energy, right, so what is the initial and final kinetic energy? If we take this gives us that half 100 times v squared is equals to 50 is equals to 50 times 16/25. So 50 times 16/25, that gives us 32 u squared, right? Okay, so, and for the second scenario, this gives us half times 100 times v prime squared is equals to, that gives us 8u squared. Okay, so initially, so what's the ratio of the kinetic energy lost, right? So the kinetic energy lost in the first scenario is 40u squared over 32u squared, and because we want to find the, okay, so this is 8u squared, okay, and in the second scenario, is going to be 40u squared minus 8u squared. So kinetic energy loss is 32u squared. So the ratio of the kinetic energy lost, right, or change in kinetic energy from the first case to the second case, right, is 8u squared to 32u squared. And that simplifies down to 1 to 4. So E is the answer. Okay. So in what can we learn from this question? We can learn that in an inelastic collision, right, in a perfectly inelastic collision, right, where the two objects stick together, it's actually quite simple to analyze the final velocity because if you know the initial velocities, you know the initial momentum, and you know that the final momentum, because the two objects are stuck together, right, there's just one unknown. So in some sense, in a perfectly inelastic collision, the the two linear simultaneous equations simplify down to just one linear equation, right? So that's easy enough. So yeah, so that's the main takeaway for this question. And in order to find the kinetic energy, right, remember kinetic energy is not conserved in inelastic collision, right? And so in order to calculate the kinetic energy that is lost, right, or the final kinetic energy, right, in order to calculate that quantity or any quantity related to that, right, you need to go through momentum. Okay, you need to use momentum to figure out the final velocities. Kinetic energy won't help you there. Okay. So yeah, if not, that's all for this question. I'll see you in the next question.